All right, we are going to work some horizontal class practice problems. I'm going to work question number 1 and question number 3 with you today. These are problems that we typically work in class, and so this video is intended to be a brief overview of how to work the problem. So I'm basically just going to take you through the process. If you need more information about some of the content and how you are supposed to know some of these facts and values that are discussed in this video, you can go back and watch the full lesson on up and down free fall that's posted on my website. So I'm going to start off by making a chart, and we are going to put our chart right in the middle of the page. For my visual learners, this is going to be very helpful because we are going to basically visually divide our page so that we have one side that is designated for horizontal motion, and then we have one side designated for vertical motion. What you're going to find as you work through these problems is that you are going to be using the same equation every time on the horizontal side, and on the vertical side we will have some variation, but most often we're going to find ourselves using equation number 4. So this is going to be good for helping build that repetition. And for those of you who learn by seeing, you're going to notice a visual pattern here, and that hopefully will be helpful to you as well. So I have introduced the idea of using this list in order, DVAT, for this particular topic. Now, I don't normally ask you guys to do things out of habit, but because of the variety of types of questions that we're going to get, I am asking from the beginning that we just list our variables while we are studying projectile motion here in this order, because it's going to give us a concrete template that we're going to be able to use for all the different types of projectiles that we're going to discuss. So DVAT over here on the horizontal side, this is our displacement. Everything is going to be forward or in the positive direction for us. This V is a constant velocity in the horizontal direction, which means that this acceleration does not exist. We have an acceleration of 0. We will always use total time for any calculations involving horizontal motion. The object is moving horizontally the entire time that it is in the air. On the vertical side, this D is our displacement. So depending on what the question is asking, it could be negative if the displacement puts our object below where it started. It could be positive if the displacement puts our object above where it started. So you can have positives or negatives here. Because we have our speed changing on the vertical axis, we're going to use this V in our template as our initial velocity. If our object starts at the highest point, then that would be a velocity of 0. If it does not start at the highest point, it's going to be some other number. So make sure you are interpreting where the object is physically located, and is it being sent upward, or is it starting from the top so that its beginning motion is straight down. Our acceleration here is going to be the acceleration because gravity is acting on our object. And so on the vertical side, we will always use a negative 9.8 meters per second squared. Now, on the vertical axis, we could have two different times. We could have a half time and we could have a total time. For this particular topic, our objects are starting at the top, so it's going to be the total time, but I want us to go ahead and just indicate here that this T is our total. If we are working a problem where we also have a half time to consider, then add that as an additional item on the list. And so what I told you guys in class was that we are going to be using this template to help us organize our information so that we have vertical and horizontal motion, but we said that the one thing that's going to connect our two axes is the total time. So I'm going to put on this template an equal sign here, because the total time along the horizontal axis is the same total time along the vertical axis. Okay, so here's our template. So now we're going to read the problem and we're going to go from here. A rock is thrown horizontally at 22 meters per second from a 315 meter tall building. How far from the base of the building will it land? So I am going to give you guys an illustration here we have a rock that is being thrown from the top of a building. So here's my building. It tells me in the problem that it's 315 meters tall. And so we're going to take our rock. We're going to throw it forward or horizontally with this speed of 22 meters per second. Now the rock is going to go forward and fall, something like this. And the question is asking how far from the base of the building. So they are asking for this displacement, okay? Now the pictures are not required of you for grading purposes, but I will use them whenever I go over problems with you because I personally find it extremely helpful for you to understand what information we have given you, because everything needs to be identified as either vertical or horizontal, and I just think that the drawings help to clarify that for so many students. So now we're going to list our information here. I'm going to designate the horizontal side in my blue pen for today. And so if you're not familiar with X and Y, the X-axis is the horizontal axis. So we are being asked for this displacement. This is the question we must answer in order to complete this problem. We are told in the problem that the rock is thrown horizontally at this speed. If you look at my picture, this horizontal arrow is telling me that this velocity of 22 meters per second is my horizontal speed, so that goes there. Now, we are also told from the problem that we have vertical displacement. So the y-axis is the vertical axis. And so my object is going to land on the ground below the building. So we're going to list this as a negative 315. And then because vertically speaking, it is going to go down. It starts at the highest point and drops from there. Then we are going to list our initial velocity as being 0 meters per second. So this is what we know to start the problem. Now, the question is asking me for my horizontal displacement. So horizontal motion is going to be V is equal to D over T. There is no acceleration. So this is the equation we want to use because it does not include an accelerating object. I can see from my list that I know what my velocity is, and the question is asking me to solve for my displacement, but I don't know what this time is. Time is not currently on my list, so I'm going to have to go find that information in order for me to be able to finish the problem. So once I figure out what that time is, I will then come back and plug it in here. So I'm going to choose to pause on my horizontal calculations, and I'm going to come over here to my vertical motion. And I'm going to see that I have enough information on my list that I could calculate the time that the object spent in the air. Because gravity is acting on the object to pull it downward, I can take the displacement that it experienced along with the effect of gravity and use that information to calculate how much time it takes to fall. So I am going to use D equals VIT plus 1/2 AT squared. And this time is the same time that I need in the horizontal direction. Remember, total time is the same on both sides. So if I can figure out what this time is, now I can finish the problem. So I'm going to plug my numbers in. Negative 315 is equal to, now all of this information right here gives me a full value of 0. And so I'm going to choose not to write anything on my substitution because that's just going to go away. 1/2 of negative 9.8 times t squared. So now I'm going to use this equation and I'm going to solve for t so that I can finish my horizontal calculation. So this ends up being negative 315 is equal to negative 4.9 times t squared. So I'm now going to divide both sides by that negative 4.9. So this cancels out and I'm left with t squared on the right. 315 divided by 4.9 is going to give me 64.285, and there's more digits in my calculator. I'm then going to square root that in order to get this to just be t, and that gives me 8.0178 more digits in the calculator. So what this means is I have now determined how much time my object spends in the air. So this number is then going to serve as my total time for both the horizontal and the vertical motion. So I'm going to take that 8.0178, whatever else I have there, and I'm going to plug that in my equation in order to allow me to solve for that horizontal displacement. So we are going to multiply both sides by this number. and that allows my time to cancel out on the right side of my equation, so I just have D equals. On the left side, I want you to use that answer button, we've talked about that before, to make sure that you get all of those decimals times your 22, and that is going to give you 176.39. Now we want to take this answer and we want to round it for significant figures. So horizontal velocity was given to us with 2 sig figs, displacement with 3 sig figs. These are the only measured values, so we're only going to use these to determine our sig figs. The least number of significant figures we were given was 2, so sig fig 1, sig fig 2. We are going to say 1, and then this 7 is going to get bumped up, followed by a 5 or greater, we round up. And then this is in the 100s place, so I'm going to add a 0 there to make that a 100, so it's 180 meters as our official final answer for this question. Now we're going to skip ahead and we're going to look at question number 3. Again, I'm going to take my little chart and I'm going to put it right smack dab in the middle of my paper in order to split my X and Y information in half so that they are separated. Again, X in the horizontal direction is always 0. This time must always be my total time. Here, this is specifically the initial velocity. If we needed a final velocity, we would just add it down here on our list, okay? Then our acceleration, our acceleration is always going to be the acceleration caused by gravity over here. So this is a negative 9.8 meters per second squared. And then in order to allow me to use this time on both sides, it has to be my total time. If for some reason I need my half time, I'll just add it to the bottom of the list. Okay. So now the problem says that we have a baseball pitcher and they are going to throw a ball. So here's my pitcher. They're going to throw a ball to home plate. So home plate is over here. And they tell us that he throws the ball at a speed of 40 meters per second. And they're telling me specifically he's going to throw it perfectly horizontally. How far will the ball drop on its way to home plate? So we know that in real life the ball is going to do this. So they want to know how far does the ball drop? So by the time it goes from here to here, how far is that drop? And so that is my unknown for this question. They tell me that the plate is 18 meters away from the pitcher. So let's put our information on our table. We have a horizontal displacement of 18 meters. They gave us the horizontal velocity of 40 meters per second, and they want to know what this vertical displacement is. So now we're solving for displacement on the vertical axis. Because this object starts at its highest vertical position, on the vertical axis, the initial velocity is 0 because velocity at the highest point or velocity at the top is always 0. So in order for me to solve this problem, I need to use D equals VIT plus 1/2 AT squared. Again, this will come out to be a value of 0. So I would have D equals 1/2 of gravity's acceleration. And then, once again, that pesky time is missing. I don't know what this number is. I've got to figure out what my time is so that I could then square it in order to solve this problem. So I'm going to put that on pause. I'm going to come over here to my horizontal information. Horizontally, we're going to use V equals D over T because the object does not experience an acceleration. I'm going to say my velocity is 40, my displacement is 18, and I can use that information to solve for my time so that I can then know what this total time is. And remember, total time is the same on both sides. So if I can find my horizontal time, then I know my vertical time. And because the object falls from its peak, it's the same time on both sides, and then I can finish the problem. So I'm going to take my time and I'm going to multiply both sides by t. Remember, anytime your unknown is in the denominator, this should be step number 1. So my times cancel on the right. I have 18 is equal to 40 times t. So now I'm going to divide both sides by 40. The goal here is to cancel out my 40 and leave me with t equals. And then 18 divided by 40 gives me 0.45. Now, there's no dot, dot, dot here, because this is exactly what it comes out to. There are no lingering decimals, so that's kind of nice. So now I know that my time is 45 seconds. So I'm going to use that here, which means I also know my total time on the vertical axis. So I'm going to plug in 0.45, and that's the value that is then going to be squared. So now I can grab my calculator and actually calculate this vertical displacement. So 1/2 of negative 9.8 times 0.45 squared gives me a negative 0.99225, and then there are more digits in my decimal. So let's go back and review our significant figures. We are given 3 sig figs here because ending zeros with a decimal present count. We are given 3 sig figs here. So in my answer, here's sig fig 1, here's sig fig 2, sig fig 3. I didn't highlight that initial 0 because leading zeros never count. So I'm going to say D equals negative 0.99, and then this is followed by a 2. That's not enough to bump up our grade if we're looking at our average. So I'm going to leave this as a 2 meters. So here is my official final answer for the vertical displacement of this object.